Hi class, so in this video I'm going to talk to you about elements, mixtures, and compounds. The first piece of vocabulary that you need to know is what is an atom. An atom is the smallest unit of matter that retains its properties. Now this is a little bit hard to understand, but because we use it kind of interchangeably with the word element. But an atom has a nucleus, and now this is kind of the traditional Bohr model of the atom, but atoms don't usually look like this, but we're going to use it for now. In the nucleus, there are protons and neutrons, as you may have learned from the atomic structure video. And the electrons are negative, and they're surrounding the nucleus. The nucleus is shown here very big, but it's actually quite small compared to the size of an atom. And we'll talk more about that later. If you break this down, so if you were to collide it like in the Super Hadron Collider that's found in CERN, Switzerland, shown over here on the right, it's actually underground, but this image down here at the bottom right shows you kind of the location where it is in Switzerland. And the picture on the top shows you kind of a cross-section of this super collider. So the way that they figure out what stuff is made out of is that they shoot atoms in this circular pattern, and then they collide them with each other and see what comes out essentially. It's a little bit more complex than that, but that's kind of the basics. So if you were to break this atom down, this nitrogen atom over here on the left down, it wouldn't be nitrogen anymore, because nitrogen has 7 protons in the nucleus and it has 7 electrons around it. So once you break it up, it's no longer nitrogen. But while it has 7 protons in the nucleus, there are 7 pluses here, as you can see. 1, 2, 3, 4, 5, 6, 7. While you have 7 protons, it is nitrogen. So it retains the properties of nitrogen as long as it has those 7 protons in the nucleus. But once you break it up, like in the super collider over here on the right, it's no longer nitrogen. So what's an element then? An element is a pure substance which is made out of only one kind of atom. So I've used these shapes here, squares on the left and triangles on the right, to show you that it's something that is pure, right? So over here, there's only squares. And over here, there's only triangles. Now if I gave you a substance, like if I gave you a lump of coal, that would be only carbon. So, but it would be represented by more than just one triangle. It would be millions and billions of triangles. Sorry, I'm screwing up my triangles here. So they can be individually by themselves, or they can be together in a molecule, which I'll go over in a moment. So what are some examples of this? Well, as I said, coal is a good example. Coal is only carbon, the letter C, right? Capital C. And another example is oxygen, right? The stuff that we breathe, that's the 21% of the air. And the formula for oxygen is O2. The gas that we breathe is 2 oxygen atoms that are bonded together. So again, people get this thing confused, right? What is an atom? What is an element? What's the difference? Well, if you think of Legos here on the left, each one of these Legos on the left by itself is an atom. If you break it down, it's no longer what it used to be. But if you take like only this green section, right? That's an element of green Legos, or the element blue Legos. So an atom is a single unit, where an element is a sample that is pure and contains only one kind of atom. I hope that clears it up a little bit. Okay, the next thing you have to know is what is a compound. So when you have 2 atoms, so here we have a triangle and we have a square, when they're touching, when they're bonded together, that particle is called a compound. So you can have obviously more than one of that particle. So what are some examples of a compound? Well, you could have sucrose, sugar, the sugar that is found in like you put in your coffee, for example, is sucrose, and carbon dioxide, right? The stuff that we breathe out. Those are both compounds. So now you gotta think about, well, what is a mixture then? A mixture is a mixture of 2 or more kinds of particles. So you can see here that you have these two circle particle atoms that are touching each other. That's one particle. And there's two of those. And then you have these individual triangle particles, which are also atoms, and they're separate. You can see that the word particle is basically anything that's separated from any other particle with a space. So you can see that there's this space in between the particles, right? And if there was no space, then there would be fewer particles, right? Because they'd actually be touching. So what's an example of a mixture? Well, if you were to put salt and pepper together, right, that would be a mixture. Or if you were to put ice cubes and liquid water together, right, that would be a mixture too. So two or more kinds of particles. Now in this case, they're actually both H2O, but at least physically they look a little bit different, right? The ice versus the liquid water. You have to know that there's two kinds of mixtures. There's heterogeneous mixtures and homogeneous mixtures. Heterogeneous mixtures have different composition in different parts of the substance. So for example, as we said, we have our cup of water with our ice cubes that are floating at the top. That would be a heterogeneous mixture of different H2O molecules. Or if you were to put in a glass of water, you'd pour some marbles, right? The marbles would sink to the bottom. And that would be a heterogeneous mixture. You can actually see that in different parts of the sample, it actually looks different. So the composition is different. So those would be heterogeneous mixtures. And in a homogeneous mixture, the composition is the same throughout. So for example, if you were to put sugar in water, and you were to stir it up, right, the sugar would dissolve, and it would be the same all the way through. That would be an example of a homogeneous mixture. So the last definition you have to know is what a molecule is. A molecule is a particle that contains covalent bonds. So we haven't talked about what covalent bonds are yet. We're going to talk about that much later. But these are basically bonds are happening between electrons, and this is when the atoms are sharing electrons. For simplicity's sake, as long as the atoms are the same, right? Notice that they're both green circles. We can assume that they are sharing the electrons because they're both pulling on the electrons equally. Again, for simplicity's sake, you can call a molecule something that has the same atom, right? They're both the same. So for example, as we said, oxygen is a molecule because both atoms are the same. Same thing with hydrogen gas, right? H2. Both atoms are the same, so they're pulling on the electrons equally. Okay, so let's see if you can try out some real-life examples. Air, cake, and diamond. So let's try out air first. So as we know, air is oxygen, nitrogen mostly, right? That's 99% of the air is both oxygen, 21%, and nitrogen, 78%. So then we know it has to be a mixture. Now is it heterogeneous or homogeneous? So this kind of depends on the smoggy day, you know, and you're really far away from the city. You can see the smog sitting right above the city, and that would be more of a heterogeneous mixture because above it would be clear and it would be smoggy. But in general, you know, when we're in class, right, the air between us looks all the same. So you would say that's more of a homogeneous mixture. You could even say it's a homogeneous mixture of elements. Or you could say that, see, they're both molecules, right? You could even say that they're a homogeneous mixture of molecules. Cake. So we have this picture here on the right. A cake would be, in this case, it would be a heterogeneous mixture. And as you can probably tell, it has these different layers, right? Red and yellow, red and orange and yellow and green and blue, right? And then there's the sprinkles on the outside. There's the M&Ms in the center, right? There's this icing stuff on the outside, right? So there's different actually parts, and they actually looked at like they're made out of something different in each part. So this would be a heterogeneous mixture. And in the last example is a diamond. So as you may know, diamonds are made out of carbon, but they're not just carbon atoms. They're actually carbon atoms that are bonded together in three-dimensional structures, which we'll talk more about later in this year. But this three-dimensional structure is actually very strong, and because all the electrons are being shared between the atoms. So this is so diamonds are actually one large molecule. The diamond is a molecule. So in this video, I've tried to review with you what the difference is between an atom, an element, a compound, and a mixture. They're all different kinds of particles which can interact with each other in different ways. And remember that there's two kinds of mixtures. There's heterogeneous mixtures and homogeneous mixtures. Thanks. Have a good day.